With this lesson, we will be going through, or this video, we're going to be going through the entire lesson. So it's going to be a lengthy video. This is really good if you've missed the day of class, or if you didn't really understand it very well. It's nice to have something else that you can look at and refer to, and maybe go through the practice problems again. So I'm going to go through the entire lesson here. We're going to be specifically dealing with distance formulas, midpoint formulas. We'll get into some functions as well, identifying functions. So first, let's go through our distance formulas. Here is our distance formula, and typically you've seen these before. You've got them on the Ames reference sheets. You can go back and refer to those as we do these problems. But the biggest thing is going to be labeling. I find that's going to be the area in which students mess up every once in a while. All right, so here is our 2 points, and we're trying to find the distance between these 2 points. Now, here is our formula, but we've got all these x2s, x1s, y2, y1. We've got to identify what this x2 is, what this x1 is. Well, if we look here, this is one ordered pair, this is another ordered pair. We have an x value and a y value. I also have an x value here and a y value here, so I need to label these. So I'm going to label this one x1, y1, and this one x2, y2. I can really label them anything I want. I can go x4, y4. It doesn't really matter as long as these two correspond. These are both 1s. These are both 2s. And again, this is my x value. This is my y value. So now that I have that, I'm just going to plug it into this formula and actually solve it. Reduce it as far as I can. Now, I kind of skipped ahead a little bit because most of you have seen this one. But that's basically all I did. I took my x2 value, which was 3. I plugged that in here for x2. Minus -6 squared. Now notice how using our order of operations, we have to do everything inside of these parentheses first, then we can square it. So that would be about the only time that students get messed up every now and then. So, but square root of 81 should have been the distance, which is 9. If you were to graph these 2 points, you would see that they are 9 units away from each other. All right, so let's try another one here. This one I'd like you to go ahead and do using the distance formula. I'd like you to push pause in the video now. Then whenever you're done, then I'd like you to work out the problem. Whenever you're done working out the problem, come back and push play. Check your answer here. This one got a little bit more complex only because this one is not a whole number. This is 3 radical 2. So you're going to have to actually be able to do that and reduce it just as far as you can. We've got the square root of 18. When we do that, we look for any sort of perfect squares on the inside that we can take out. We know that 9 is a perfect square. Square root of 9 is the same thing as 3. So 3 square root of 2 would be our answer. All right, now this one's just a little bit different here. I'd like you to go ahead and do this one on the graph here. You can find the distance between these two. Just to make it a little bit easier, I went ahead and I wrote it up here for you. But go ahead and do that one. Find the distance between these 2 points. Push pause now. Whenever you've worked out your solution, come on back and push play. Check your answer on this one. This one was the square root of 26. We cannot reduce it any further than that. There is no perfect square in the square root of square root of 26. So that's as far as we can go. That is our distance there. And we like to leave it in this radical form because this is considered an exact answer. It's not rounded in any way. All right, now let's get into the midpoint formula. This is our midpoint formula. Again, we have these x1s, these x2, y1, y2, all of this. These are all divided by 2. So we're going to basically use the same process. Whenever we get our 2 points, then we're going to label those 2 and then just plug it into the formula. Is really all we're going to do. All right, so I've got 2 points here. I've got -4, 2, and 6, 8. Now I'm going to use the same process. I'm going to label each one of these. This one is x1, y1. This one is x2, y2. If you wanted to, you could label this one x2, y2. This one up here could be x1, y1. It really doesn't matter, so long as if this one is a 2, this one here has to be a 2 as well. Now we're just going to plug it into our formula here. So we've got x1 was -4, x2 was 6, divided by 2. Then we've got 2 plus 8. This is my y1 plus y2 divided by 2. That leaves me with my midpoint, which is 1, 5. 1, 5 is my midpoint on that one. All right, I want you to go ahead and try these 2. I've got 2 of them listed there. Push pause on the video now. After you've worked out your midpoint, then come on back and push play to check your answer. Check your answer here. You should have had 5, 0 and 2, 3.5. Now on this particular one, some of you may have written 2, 7 halves. That's fine too. Either way is just fine. Whenever you're entering it in online, sometimes I require that you write it in decimal form, but if you want to just, for right now, leave it at 7 halves, I'm fine with that on tests and so forth. Okay, go ahead and try this one. This has just got the graphs. You're going to have to identify the points here, then plug it into your formula. So go ahead and try and find the midpoint of this graph. Push pause now after you've obtained your answer. Come on back and push play. Check your answer here. So 0, -2 was the midpoint, and you can kind of see that on the graph here. That's 0, -2. Here's your midpoint. Now we're kind of done with the review portion. Now we're going to get into section 3.1, which is specifically dealing with functions, identifying what is and is not a function. So let's kind of go through what a function is. A function is a relationship that depends on something else. So we're going to get into, it has inputs and outputs. The biggest thing, this is the one that we need to really pay attention to, is that each input has exactly one output. That is a definition of a function. For every one input, there's exactly one output. If you can remember that and get that part down, then you'll be fine with functions. But it gets a little bit confusing because we just have to remember that. So if you can write that down, the part there that's in this purple fuchsia color, every one input has exactly one output. Okay, so now let's try to kind of apply that just a little bit, because if it has more than one output, then it's not a function. So we've got this. All right, so let's look here. Every one input, I've got an input of 5, has one output of 3. So far, so good. 6, every 6 has one output of 4, so we're fine. Every 7 has one output of 5, and every 8 has one output of 6. So this one is definitely a function. Each input has only one output. That's all it has. So this one is therefore considered a function. Let's look at one that's not a function now. So if we look right here, this input of 9, if I input this 9 into this equation or into this function, into this the equation, I get two different answers. I get a 5 and I get a 4. So this one is not considered a function. You see that this 9 is repeating, and we get different outputs is really the thing, because remember, for every one input, there's exactly one output. So this one input of 9 gave me two different outputs, so this one is not a function. Okay, so look at this one. This is our temperature here. This is a random month. It's not our temperature in Arizona, but it is a temperature up north. We want to identify, is this one a function? I want you to think about that for a little bit. Remember, the definition of a function is for every one input, there is exactly one output. So let's kind of go down the list here. For the first day of the month, there's only one output. For the second day of the month, there's only one output. Now this is like the high temperature of the day, if you will. So there's only one high. There can't be two highs. And if we continue down the line, all of these inputs, every one input has exactly one output. So this one is considered a function. Now this gets a little bit confusing, because if you look right here, I have 2 days in which the high was 30. But remember our definition of a function. Every one input has exactly one output. We really don't care what that output is. It can be the same. All of these can be 30 for that matter, and it'd still be a function. So that's a part that gets a little bit tricky, but just remember, every one input is exactly one output. For this, the 7th, every one input, there is only one output. That is perfect. This one is a function. Okay, the third day of the month has only one output. This one is a function. What if we were to switch these two, though? If I made temperature the input now, and the day of the month the output. So let's look at this. Well, the temperature of 25 had an output of 1 in this case, so that one we're okay on. But let's look here. On 30, I had two different ones. 30 corresponded to 2 and to 7. So for this one, if temperature were our input, then this one would not be a function because it has two different outputs. All right, now that'll get more confusing. Well, hopefully it gets a little bit less confusing, but it's pretty confusing initially. So as we go throughout, hopefully it gets a little bit less confusing. The more you practice this, the better it will become. But remember that every one input has exactly one output. If you can do that, then you'll be fine. All right, so I'm going to give you a table here. I want you to tell me if this one represents a function. So here is our table. Don't even worry about pushing pause. Just look at that one and you can identify whether this one is a function. Every single input here has exactly one output. That is true, so this one would be considered a function. Another thing that we want to review here is that the output is referred to as a range. These are our y values, if you will, if you're used to that. The input is referred to as the domain. Okay, so the x values are the domain. The output, the y values, are considered the range. All right, let's look at another one here. Here's another table. And again, we're going back to the question, does this one represent a function? So we have to go down there and look. Remember, the definition of a function is for every one input, there's exactly one output. If you notice here, the input of 1 has two different outputs. If I input 1 into this equation, I get an output of 3 and 4, two different ones. So this one would not be considered a function. All right, now I can also write these as an ordered pair. This can be 1, 3. This one would be 1, 4, 2, 5, 3, 6. You'll see that written that way quite often as well. So don't let that kind of throw you off. All right, but let's look at this one. Is this one a function? I want you to push pause now. I want you to go through this, determine whether it's a function or not, then come on back and push play. If we look right here, this one is not a function. 65, your height, if you're 65 inches tall, this has two different outputs. So this one is not a function. Remember, for every one input, there's exactly one output. For this one input of 65, I have two different outputs, so it's not a function. All right, what if we were to switch those two around, though? If we made the weight the input and the height in inches the output. Push pause now, determine whether this one is a function, then come on back and push play. Hopefully on this one you identified that 161, the input of 161 gave us two different outputs, so this one is not a function either. Neither one of these two are. Okay, and it doesn't really matter what the input is. If one input gives us two different outputs, it's not a function. Let's look at these two. Now, I went back here and now I'm listing them as ordered pair. Remember, the input is considered the x value. The output is considered the y value. So the 7 here is our input. That gives me an output of 3. So you want to look through this list here and determine if this one is a function. Same thing for number 2. So go ahead and push pause now after you've obtained your answers. Come on back and push play. Check your answer here. The first one is not a function. The reason why is because our 12. The input of 12 has two different outputs here. This one on number 2 is a function. Now, one thing I forgot to ask you to list is the domain and the range. Remember that domain is always our x values, 7, 12, 22, 4, 12, and 10. Notice how I just list the 12 ones. There's no need to list it twice. It's kind of redundant. The range are all of the y values, all of our output values. So 3, 8, 10, 1, 9, and 11 are all of our outputs. Okay, real life examples of a function would be the amount of homework, the amount of hours you spend on homework versus the grade you get in the class. Typically speaking, the more time you put into homework, the better your grade will be. You yourself. We're not talking about students in general. There are some students who don't do as much homework and might get a better grade, but had they put in more effort on their homework, they themselves would get a better grade. That is a function. Another one is the amount of education that you receive versus the amount of income that you make. And the last one that we'll go through for the moment is car accidents. The more car accidents you have, this is a function, the more you will pay in your insurance premiums. Okay, so now we're going to go through this one. This is a different way to represent a function, is graphically. We're going to have to determine it. And the way that we'll do this is what we call the vertical line test. And what that means is we're going to draw a vertical line right down this graph. So right here we want to ask ourselves how many times does this one intersect the graph. We notice right here it intersects only once. So far so good. It's a function if it can intercept once and only once, and that's it. Then it is a function. So it intersects only once over here, and over here it only intersects once. So this one is a function. Now, the way we kind of interpret that, well, let's go through the next one, then we'll kind of go through it. So this one here that I'm going to draw, again, we're going to do the vertical line test. We're going to draw straight up and down. How many times does this one intersect? This one intersects more than once, so this one is not a function. It does not pass the vertical line test. If we were to draw, or if we were to write the points here, let's see, this is 1, 2.5, it looks like, 2.5, and then I've got 1, 2.5, so this one's probably 2.5, 2.5, and down here it's 2.5, maybe negative a quarter. So for the input of 2.5, I have two different outputs here. I've got somewhere around up here 2.5, positive 2.5, and down here is negative 0.25. I've got two different outputs, so that doesn't work. This one is not a function. So if you draw this vertical line and it intercepts once and only once, it is a function. More than that, it is not a function. All right, try these two. Determine if it's a function. Do the vertical line test. Push pause now after you've obtained your answers. Come back and push play. Check your answers. This one is a function. It does pass the vertical line test no matter where we draw that line up and down. It only intersects once. This one, however, we look here, it intersected 1, 2, 3 different times. So this one is definitely not a function. Okay, try these two. Push pause now after you've obtained your answers. Come on back and push play. Check your answers here. Number 1 is a function. For every input, we've got a -2, 5, -1, 7. All of these only have one output. The second one, however, if we drew the vertical line, it intersects twice. That one is not a function. Now, performance in class, let's think about this one. Is this one a function? This gets a little bit confusing. Remember, the rule for a function, though, is if every one input has exactly one output, it is a function. So think about this one for a second. Let's go through it. This one, every one input has exactly one output. Every 92 corresponds with an A. Every 96 also corresponds with an A. It's okay that these two are the same. Every one input has exactly one output, so that one is a function. This works. Now, if we were to switch these two around, we made that the letter grade as the input and the percentage as the output. Would that work? So we'll go down here, and if you got an A, I have actually two different outputs. I have a 92 and a 96. So this one would fail a function test. This one is not a function. Okay. So, and then remember that the definition of a function is for every one input, there's exactly one output. This one input here has two different outputs. So that one is not a function. All right, well, this concludes the video here. You can go back through it and watch it a couple times. Hopefully you found that beneficial. I will try to put one of these videos at the beginning of each of the homework assignments, so that way you can have a chance to review it if you want to.